In this video, I'll be working through the question you see on the screen from the Pure Maths paper 3, specifically paper 3-2 from Cambridge A-level exams from 2023. I'll be doing all this on the board. Hopefully it'll be a lot like you're used to your teacher doing in a classroom. If you want other questions from this paper, you should be able to find it in a playlist in the description below. And if you find any of my videos useful, I'd greatly appreciate liking, subscribing, or even sharing it to a friend sitting the exams this year or next. In question 10, we're given the equation of this curve here, as you see up here, and we're asked to find the exact coordinates of m, which we're told is the maximum height of this curve. And then in part B, we're going to be asked to find the area underneath this curve. Okay, let's start off with A, finding the maximum, finding m here, which is the maximum of the curve. When you see something like maximum point, you should be thinking dy dx. dy dx equals 0. And that's what we're going to end up using here. The derivative of y here, it's two expressions multiplying each other. So we're going to go ahead and use the product rule here. So the product rule, how I remember, at least well, it's easy to remember because you can do it in either order. Quotient rule, I have to look up because it matters which order you do it in. But I leave the first one alone, x plus 5, and I multiply by the second one differentiate. So just to make it a little easier, I'll put a bracket around and put to the power of a half. To differentiate this, we'll use the chain rule. A half times this bracket minus 2 over x, take 1 away from this power, we get minus a half, and then multiply by the derivative, multiply by the derivative of what's inside, because we would have substituted here. That's what we're doing as a bit of a shortcut. The derivative of that is minus 2. The derivative of inside here is minus 2. And then, so that's the first half of the product rule. Second half, we leave this guy alone. We get 3 minus 2x power of a half multiplied by the derivative of this guy, which is 1. So just about fits in there. Nearly ran out of room. Okay, we need to clean this up a bit. First of all, we have a 2 multiplying by a half. They cancel. We're left with that minus though. We have an equals, thankfully, and a 0. So let's just move everything over to equals. This term has a minus here, so it'll turn into a plus. So let me write that again on this side. X plus 5 times 3 minus 2x to the power minus a half is equal to 3 minus 2x to the power of a half. Now it might be useful now to start thinking of this as the minus a half been on the bottom row. So let me change that. Let's put it on the bottom row and let's change it back to a square root. Students, I think, find it much easier to deal in the square roots. That's what I had here. I had 3 minus 2 to the power of a half minus a half. Minus put on the bottom row, half was the square root. And again, let's change this one to a square root. I find students find it a little easier to see. Equals here, make it clear. Let's just multiply this by both sides. So we end up with x plus 5 is equal, these are the same, 2 square roots multiplied together, square roots cancel. We're just left with 3 minus 2x. Let's clean this up. We get 3x's on the left and we get minus 2 on the right. X is equal minus 2 over 3. Just check my notes. Yeah, that's right, fine. Now, strangely, so many students, good students, bad students, so many students do the same mistake every exam, every test I do in class. They leave this as the answer. They ask you for the coordinates of m. That means I want to find out this number, minus 2 over 3. But I also want to find out the y number. So we're not finished, okay? We're not finished when you find x. Stay going. Make sure to check the question. Do they ask coordinates? You need x and y. Okay, we have y. Y is right here. Y is equal to x. Well, we know x. At this point, at the point we're looking for, we know x. So we can put in minus 2 over 3. Well, let's put it in the slow way. Sorry, 2 over 3 plus 5. That's 15 over 3. 3 minus 2 times minus 2 over 3. Let's change 3 into 9 over 3. Make this a bit easier, and that's a power of a half. Okay, let's clean all this up. We get 15 minus 2 is 13 over 3, multiplied by, let's see, that's minus 2 times minus 2 is 4, plus 4. 9 plus 4 is 13 over 3 as well, power of a half. This all equals, this is like 13 over 3 to the power 1. This is equal 13 over 3 to the power of 3 over 2. And oh yes, sorry, they don't give that as the correct answer in the book. Sorry, I'm sure you will get this full marks for this. But sorry, in the marking scheme, they just give you this, and if you put this into a calculator, the calculator will tell you 13 square root 39 over 9. I'm sorry, that's the answer to give in the marking scheme, which is correct, and that's also correct. I guess the advantage of this is there's no power to something strange. Power of 3 over 2 is a bit off-putting to some people. Still, I think this one looks a little neater. Each your own. You'll get full marks for both of them. But you might have been confused looking at the marking scheme if you got this and seen this. They're both the same. Okay, let me clean this off and we'll do part B, which is the area under this curve. Okay, part B tells us by using substitution of u is equal to 3 minus 2x, find the area under the shaded region. Well, this was all shaded in their picture. Bounded by the curve and the x-axis. So everything, well, you have the shaded region yourself on your picture. Give your answer in the form of a square root of 13. That's fine, we'll deal with that at the end, where a is a rational number. Okay, so basically that's it. We're just going to integrate y, integral of y with respect to x between these two numbers here, whatever these two numbers are, which I guess that'll probably be the first thing we should do. Let's find these two numbers. We can find that by, let's do it under here. Y equals 0 is when these numbers will be true, and y also equals x plus 5 multiplied by 3 minus 2x to the power of a half. These are already factorized, so we should be able to see x is equal to minus 5, so that's minus 5 there. And on this side, let's see, 2x is equal to 3, x is equal to 3 over 2, so that's 3 over 2. So we're going to integrate, let's see, I always mix these up between this one minus this one. So 3 over 2 to minus 5. Let me just check that's correct. Yeah. Okay, we're going to integrate that. That means integrating all of this. But they do give us a hint. They tell us, why don't you try and substitute u in? So let's write this again as, instead of this guy, we'll have u to the power of a half. So what do we write for this? No point having any x's in here, is there? X plus 5 dx. We need all u's or all x's. We could put all x's, that's easy, except it's really hard to solve. So we need all u's here. So let's do what we always do with substitution. Let me just make a little bit of room here. U is equal to that. Let's find what du dx is. That's equal to minus 2. That means dx will equal minus 1 over 2 du. So that's fine, we can get rid of dx. Put in a du, that's easy. How do we get rid of this guy? Let's just play around with this. Instead of that minus 2x is equal u minus 3, x is equal u minus 3 over minus 2. So we want x plus 5, so x plus 5 must equal, let's clean this up a bit here, minus u over 2, what's that, plus 3 over 2 plus 5, which is 10 over 2. So this is equal minus u over 2 plus a 13 over 2. That's what x plus 5 is. So I can substitute that. Let me just check my notes actually, sorry. I remember it wasn't that neat, but it's fairly messy looking. Yeah, that's correct. So let's substitute all of this in. Oh, one last thing. Let's change these numbers. These numbers are for the x's. We need them for y. Let's squeeze it in down here. When x equals 3 over 2, this guy, what's u equal to? When x equals 3 over 2, let's see, 3 over 2 multiplied by 2 is 3. 3 minus 3, u equals 0. So that one's easy, this is 0. And when x equals, let's see, minus 5, what's u equal to? Minus 5, minus 2 times minus 5 is plus 10. U is equal to 13. 13 down here. Okay, just check with us. Yeah, that's fine. And let's clean this up. Let's substitute everything we know in. Let's see, we have minus, so the integral of 13 from 0 to 13 is, I'm going to replace this instead of x plus 5. So let's see, 13 over 2 minus u over 2 multiplied by u to the half. Instead of dx, I'm going to replace it with du and a minus a half, which can come all the way up front. Minus a half. And then one last thing, let's go ahead and, well, not one last thing, we'll do a couple of things. Yeah, let me do it all here. You know what, let me do one fast thing here because I'll run out of room otherwise. 0 to 13. That's uncommon looking. We're used to looking at 13 to 0. And we can switch like that whenever we want. All we have to do is change the sign. Okay, so that's the first thing I'll do quite quickly there. And let's write this out a bit cleaner. This will equal a half the integral of, let's multiply this out. 13 over 2, that can come out front, sorry I should have done that, times u to the power of a half du, and minus, what have we got, minus a half the integral of, sorry, 13 to 0. Definitely, I'll rub this out and make more room in a moment. And I'm going to multiply this guy by this guy. I'll just double check I've got all my signs correct. U multiplied by u to the power of a half is u to the power of a third. There's a half under here. Let's leave the half there for now. Okay, these are two integrals we can now do. They're not that difficult. Power of a half, power of 3 over 2. But I'll rub all this out and we'll fit it in up here. Okay, let's move this up here. This is 13 over 4. 13 over 4. The integral of a half. Let's see, we add 1 to it. We get u, we add 1, 3 over 2. And then we divide by that new number. Divide by 3 over 2. It's the same as multiplying by 2 over 3. And that's evaluated at 13 to 0. Okay, second one, minus 1 over 4. This 2 came out. The u, we add 1 onto that, we get 5 over 2, and we divide by 5 over 2, which is multiplied by 2 over 5. And again, that's evaluated 13 to 0. Let's clean all that up. We got 26 over 6. Sorry, we don't need to do that. The 2 goes in 2 times. 13 over 6. Or, yeah, okay, the 6 was wrong anyway. It should have been 26 over 12. So 13 over 6. U to the 3 over 2. Minus 2 goes in. 1 over 10. U to the 5 over 2. And all of this is evaluated 13 to 0. Now with the 0, when it goes in, it'll be easy because that's 0 and that's 0. So we could actually ignore this 0, just the 13 going in. This becomes 13 over 6, 13 to the power of 3 over 2, minus 1 over 10, 13, 5 over 2. And you can actually go ahead and put that in your calculator if you want at this point, but we can do it a bit more mathsy. Let's see, we can take 3 over 2 out of both of them. So we will get, we'll get 13 to the power of 3 over 2, 13 over 6 minus 1 over 10 and times 13. You see what I mean there? 13 to the power of 3 over 2 comes out this one time. 13 to the power of 3 over 2 comes out this 13 times. So that's where that 13 appeared from. And this is what they wanted. They wanted the square root of 13. Oh, I need to take another 13 out. I'm sorry. Let's go ahead and take 13 to the power of a half. Take the extra 13 out, we'll get 13 squared here over 6 minus another 13 squared over 10. Let's just combine that. Sorry, quick edit while I checked my notes. This was correct, and the answer there is square root 13. That's this guy. And I just put this in a calculator, save me finding common, would be 30 on the bottom here, or 15. Oh well, 30, and then they must cancel in because we get 169 over 15. And that's what they wanted. They wanted the answer to be in the form of a square root 13. In this case, a must just equal 169 over 13. Sorry, over 15. That divides in evenly. Over 15. So that answers that entire question. I feel I rushed that one a little bit. Apologies for that. I'm tempted to go back over and redo it, but I won't because I'm really late on time. I have the birth of my second child coming up in any day now, so I'm really rushing to finish this exam. So I'll get started on question 11 any minute now. If you have any questions for this question 10, put them in the comments below. I'll do my best to get back for you. Thanks for watching. Have a great day.